So for this video, we're going to be doing some rigging. Now, a couple disclaimers before we actually jump into it. This is going to be a more theory-heavy video compared to the other ones. We will be discussing this over in class, but there are some things that we do have to keep in mind as we're working. So having this in video format might help as well. So I'm going to try to my best to keep this as concise as possible, but also explaining a bit of the theory as to what we're going to be doing. So rigging is the process by which we can actually start deforming our model for animation. We're going to be creating a skeleton and we're going to be assigning our geometry to said skeletons to later be able to pose and deform, kind of like making a puppet or a stop motion figure, um, right? Other disclaimers I kind of want to throw in there is that this is going to be a rather basic rig setup. It's going to be a little bit unorthodox. Again, I kind of want to just cover the process and the logic of it, not necessarily the entire workflow or pipeline for how to rig a character. So there are a couple of things that I'm going to maybe oversimplify or maybe skip ahead in some areas. Definitely topics that you will see more in depth whenever you get to the actual proper rigging classes. This is again really basic introduction to the concepts and right, we're not going to be delving into having multiple rigs or IKFK systems. It's going to be a really bare bones model. So this is for any riggers or any experts, just letting you know, right? Not to give you guys an aneurysm here. But again, I kind of just want to showcase the general logic as to how this works. So mainly, as I was talking, um, one of the first things that we kind of have to understand when it comes to rigging is parenting, right? We're going to be working with hierarchies. Essentially, one thing is going to be answering to another. So if I were to grab, for example, I have a cylinder and then I have this sphere. Let's say I want this to be a, right, sort of like a ball and joint, ball and socket type of scenario where maybe I have two areas here. It's going to be like a really simple arm. And I want to be able to rotate. Whenever I rotate this sphere, I'm actually also rotating this cylinder. Um, I would have to set up a hierarchy or a parent. Essentially, if I select my cylinder and then I select my ball joint and I press P, this cylinder is now parented to that ball joint. And you can kind of see it in the outliner where the sphere, right? The cylinder is inside the sphere. So if I move the sphere, it'll rotate or move the cylinder as well. But the cylinder maintains its own independent movement and rotation. But whenever I move the sphere, the child, right, will follow the parent. And this is really the most basic concept that you have to understand when it comes to rigging. We're essentially going to be setting up a chain where one element answers to another one, but we're going to be doing it based on joints. So go over to skeleton or over here in our rigging workspace. We can also find our rigging setup right here. We have some tools to set up our skeleton in general, right? So if I head on over the front view, maybe turn on my wireframe only, I'm going to be creating that chain. I'm going to be starting from the spine all the way up to the head. Then I'm going to focus on the arms, and then I'm going to focus on the legs. So the real basic setup here, by selecting our joints, I'm going to click once by holding X because I want to snap this to the grid. Right between the legs here, this is going to be your center of gravity, right? Our hips, where most of our actions are going to be manipulated from. A lot of motion, a lot of poses really do start from the hip because this is our, right, our center of gravity, our largest volume um, for controlling these actions. So a lot of the body is going to be answering, or all of the body is going to be answering to this one joint right here. Then we're going to set up one joint for the spine. Again, this being a really simple model, I only just want him to be able to like maybe move left and right when he's rotating. Nothing crazy. Again, rather simple. If this were a more complicated model, we might actually have to have a couple more joints for the spine. But right now, I just want three joints, one for the hip, one for the back, and then one for the head. This one's going to control, or it's going to have some influences over the top of the head over here once we rig that. And then I'm going to press enter, and this is going to be our first joint chain or hierarchy, right? You can see joint number 1, 2, and 3 all set up over here. And something that's really important to keep in mind is making sure that everything has a proper name when you're working. So for example, the center of gravity, right? We just go ahead and call that COG. And then I like to specify this is a joint. So I go ahead and write JT for joint. We can name this body or back or spine. Go ahead and name that body underscore JT. And then this would be the head underscore JT. So right off the bat, you can kind of already see that if I were to move this, right, we kind of have that similar structure that we had with the cylinder and sphere, where I can rotate it, move it around, and essentially all of them answer to this big joint over here. Something I could also do is maybe add some extra joints for the skinning. I was doing some testing beforehand, and definitely since he's so large and rotund, the skidding might be a bit more complicated for this section. But we are going to be skipping ahead. There are some things that are going to be rather time consuming, and I want to be able to just show you guys the process, not so much the entire pipeline, right? So now that I have that set up, I can start focusing on the arms and legs. So again, I can just select my joint, right, to create my joint tool right here. I can press or click once right around here, right? This is where the hip would move, and then one for the bottom of the foot. If you hold shift, it'll draw a straight line. And notice that I'm drawing in the direction where I want my chain to continue. So in the case of the hip or the leg, the idea is that the hip controls the knee. We don't have a knee, but right, if you had a little knee right here, and the knee controls the foot. So the direction has to go from top to bottom versus our hip that has to go from bottom to top, right? And in the case of an arm, and here in this case, I'm going to try something a little different for this test than what I did for the initial one I did earlier. I'm going to add another joint here, and this one might serve as our sort of clavicle, more or less, even though he doesn't really have one. Again, this is mainly for skinning purposes, and I'm going to add another one here. This is going to serve as our shoulder. I mean, maybe we want to drag this over here, but I want to test this out right now. And then one over here for our elbow, and then lastly, one for our hand, right, our little stump. I'm going to try to keep them straight a little bit, more or less. There we go. Again, since this is a quick video, obviously there are some things like orientations you have to keep in mind, but I'm just going to test it as is, see how this works. Now that we have this set up, now I have to parent these joints, because right now they are just separate islands, so to speak. They're not interacting with each other, and I want that. I want to be able to have the skeleton work with the other pieces that I have created. So before that, I'm actually going to rename these pieces here. I'm going to go ahead and name, for example, the hip. And then I'm going to specify this is the right hip. This is our screen right underscore JT. And then our foot underscore R underscore JT. Specify the direction. This is going to be, even though the clavicle isn't anatomically correct here, this is what I meant it to be. I'm just going to go ahead and name that clavicle underscore R underscore JT. Then work my way down, shoulder. Right, this will vary from model to model. JT, keep working our way down, elbow underscore R underscore JT. And then lastly, just the hand underscore R underscore JT. There we go. Now I want to be able to mirror this from one side to the other, but before that, I want to be able to parent both pieces. So the logic is you first select the child, and then you shift click on the parent, and then you press P. Now you'll notice again, the arrow indicates which is the parent. So this would be a parent and it's pointing towards the child. So if I move this piece, right, this centerpiece stays still, but if I move the centerpiece, this piece moves around with it. So now I do the same over here, and then go ahead and press P to parent, and now we have this general setup and configuration here, right? So now I want to be able to mirror this setup from this side to the other, and all I got to do is select the base joint, head on over to skeleton, mirror, and then I just want to check, right? They should all be the same behavior function, and I'm going to be changing the name so I don't have to look for it every single time. I'm just going to change the R to an L for the right left side, and then apply that, and now we have that structure, and it's already parented to the other side, so that saved me a couple clicks, and then do the same over here, and then just apply that, and now we have our setup, right? So now all I have to do is actually skin this model, and again, this process is a lot more complicated than I'm going to be showcasing here. Skinning is the process by which you assign the vertices of your model to a specific bone or joint in your skeleton. This is what will allow you to actually move it. Admittedly, skinning can be a bit of a time-consuming process depending on the complexity of your model. There are some automated processes you can do, but sometimes you might just have to do the entire process by hand. Obviously, we might not have the time for that. So we're going to try to keep it as simple as possible, as automated as possible, though I will showcase how you could edit your model or your skinning as you're working. So to set up our base skin, I'm going to select both my hierarchy, right, my main joint, and then my geometry. And then I'm going to go over to skin, bind skin, hit on over the settings, and then I'm going to be using the geodesic method. Again, this will give us like a pretty good approach. We could try heat map as well. So I'm going to try both, see which one works best for us. Go ahead, geodesic voxel, apply, and then I can just test, see how it's deforming. So you'll notice that this deformation might not be super accurate to what you might expect, right? The arms aren't moving or aren't behaving super well. And this mainly has to do with how complicated this model actually is, believe it or not, right? We have a lot of pieces. Um, Obviously, the models we're also working in class do have their own complexities and challenges, but it's a similar workflow regardless of what you're actually working on. Now, this might give us like a good enough sort of result. Obviously, we have some weird deformation going on in the arms. I'm gonna try and unbind that, just undo this. And let's see if that worked. There we go. And I'm gonna try heat map now. See if that gives us a slightly different result. In any case, I'm going to be skipping ahead and showing you guys somewhat of a better result with some manual skinning. Let's try heat map here. It's more or less the same. It's a little better actually. And the arms deforming rather nicely. Just checking the legs here. Right, it's not great. Notice that this entire leg is sort of shifting the entire body here. So we would have to properly assign the skin values to the joints. And again, to sort of oversimplify this, I kind of already did that setup over. I can show it later. Right, but the way you could sort of edit this skin is by selecting your model. We can turn on the X-ray for our joints here so we could actually see through it, and then hold right click and head on over to paint skin weights. And now you can see essentially the way this is working. We have this gradient or this alpha map over here going from darkest to lightest. Essentially dark meaning that there is no influence from the joint on the geometry, and then the lighter or whiter it gets, that's where we have our influence. So you'll notice that in our COG, there's some influence happening on the leg here, and we might not necessarily need that, right? We want this entire bone or our foot to be influenced by this foot joint that we created. So something that we can do is hold right click on the joint, select influence. Actually, we might do it over here. We can do it over here, honestly. And then paint, right? Increase our value here. We're adding, and we can paint that influence. And this will actually replace the influence from the COG over to this foot over here. And then we can hold shift to kind of blend that a little bit. So honestly, if you guys like painting, this process is sort of similar to it. Right? This is why it's called weight painting or skinning, where we're assigning our skin values to our skeleton. And I can literally test this out by just rotating. Now you'll notice that now the foot has more influence versus this one where we have this deformation over here. But again, this could be a rather time-consuming process. Definitely too long for this video. So to keep it simple, right, we are going to be leaving it as is, because this could easily be its own class, or its own like dedicated separate video when it comes to paint, weight painting is what I'm looking for, right? Because we, by weight painting, which is another term for it, we are assigning, well, the weight of the influence of the joint. So bigger weight, right, or lighter or whiter means more influence, and then the darker or grayer becomes the less influence. So you can blend here. So you could have, for example, 50% influence being shared between more than one joint. This sort of works for the arms. If you want to reorient the leg once you're done posing, you can hold right click and then assume preferred angle, and it should go back to the original 0 position that it should be its default, right? We can test things like mirroring our skin weights, and then moving this around, see if that worked. Right. And again, this could easily be its own separate hours long video on the process. And I'm going to be keeping it rather simple for this class, and we're just going to move on to the next section, which is how to add elements. For example, the eyes. Again, the eyes are going to keep them really simple. I'm just going to skin them to the head joint. Same with the crown. I could give the crown, for example, its own dedicated joint if I wanted to like pose it or do some animations. Again, I just kind of want them to follow the head. So if you want to add to a model, or you want to add a model to a skin, you can just go ahead and find skin, just apply that. And since this joint is so far away from the geometry, we might not see a lot of deformation or a lot of influence. Here we kind of do. But in this case, what I would do is just completely fill this joint to this model. So select influence, and then just completely paint this white, or we can just flood this completely, and now it's completely tied to this model. We can do something similar for the eyes as well. We can select them both. Actually, let's just do one at a time. Just apply that. This is, whoop, something broke here. Let's just swap that to geodesic. This could be due to the distance from the actual joint. So just go ahead and change that to geodesic. Then apply that. And then head on over paint skin weights. And yeah, I want this influence here. I'm just going to flip that. Paint mode. Hold up. There we go. Select influence. Select influence. There we go. Just flood that completely white. Now, whenever this moves, the eye follows. And then repeat that for this one. Just apply that, and then paint weights. Select influence. And then flood. There we go. So now all these pieces are connected to this main head joint over here. If I want to do fancier stuff like having the eyes controls and stuff like that, I would have to make other joints, right? So again, we're keeping it simple for this video. Now, this is where I might give a couple of riggers some headaches, a couple strokes here. But again, I just want to showcase the process. So I want to be able to control this model. Technically, you could already animate this mesh, obviously after cleaning up some of this skinning. Um, but obviously, this is how you would be looking at the model most of the time. Usually the joints are either hidden or separated, or you can't directly interact with them because you might break the entire model in the process. And it's also kind of cumbersome to select those joints or pieces of the skeleton that way. So what riggers do is that they'll create a series of controls using curves, right? Nerve curves to be exact. And again, this is going to be a rather unorthodox method. This is more to like showcase the general workflow, right? I'm going to keep reiterating that. So I'm just going to start by making this control over here. And essentially, I'm going to be making control for every piece that I feel needs to be posable in our model. So we might not need controls for the feet necessarily as an example, but we might need one for the hip because that's what we're going to be rotating. So what I'm going to do is I'm going to duplicate this nerve circle a couple times and then pose it or place them in the areas where they would be needed most. So for example, we have this big control. This is going to be our COG control, and then we can duplicate this by holding shift, and this is going to be our master control. This is where most or all of the controls are going to be connected to at the end of this. Again, it's just going to make it easier to select and then move around. And again, the method that I've sort of decided on for this approach is that I'm going to be directly constraining the controls to the joints. Maybe some of the riggers in the room are gasping in awe and disgust, but again, we're keeping it simple for this video that is already dragging on a bit too much. So the logic is I'm going to be duplicating these controls. I'm going to be scaling them down. And then with V, I'm going to be snapping them directly on this joint, right? Obviously, I can't see the model right now, so I would have to edit this joint once I have that set up. The idea is that I'm going to continue Control D, V, and then set that one up over here. This is going to be our spine, our back control, and then Control D, V, and then put this over our shoulder. Scale that down a little bit. Just rotate that. Make sure our rotation is set up properly. And then Control D, scale that down a little bit. Control D, V. This is going to be our elbow. And this is mainly the joints we would need, right? Just one for the back or the head, one for the COG, one for the hip, one for the elbow. We could have another one here for the clavicle. Just duplicate that and then place that over here. And then we could also use that for posing. Right. And then super important, we're just going to select everything. And we're going to hand on over poly modeling and then press freeze transformation. We want these orientations to be the permanent position for these models. So if you have any transformation data, any translation data, that will impact the model. So make sure that that is set to 0. Everything's frozen. Now I'm going to turn back our model, H, and then you'll begin to notice that some areas of our skeleton or our controls are hidden within the model. So we can just maybe make them a little bit bigger, right? The clavicle a little bigger, the shoulder a little bigger. And we can also manipulate them or change its shape for easier selection. So if I select my model or my nerve curve, obviously anytime I make a change, I would have to freeze transform, double, triple, make sure that you have that set to 0. And then I can hold right click and then go over to control vertex, and now I can select these points and sort of basically make the control whatever shape I want. It's ever more convenient for selection. So for example, these points here, keep selecting the skeleton. There we go. There we go. Deselect these. Just kind of sculpt the shape a little bit. And the idea is that I'm able to see and select this control from any point. Honestly, the shape of your joints, or I should say the shape of your controls, can be anything, right? So long as you can select them properly, so long as you can see them, so long as your animators can see them, just select all here. And for the case of the clavicle, for example, I just moved this and make it a little smaller and kind of shape it more or less where that clavicle would be. And since I'm moving the clavicle in that direction, this orientation still stays in this place, but I'm selecting it from this region over here. Again, this is more or less up to you, up to your preference. Obviously, whatever is easiest to then later select. Funny thing is that you guys are going to be animating the rigs you make, so keep that in mind. Make sure that you don't get too lazy in this step. For example, just making everything more visible, easier to see, right? And now make sure that everything is properly named, and because I'm paranoid, I'm going to be freezing transformation, deleting history, just in case. Right, you can never do this too many times. Now I'm going to go ahead and name my joints or my controls. The name I'm going to be assigning is going to be similar to the joint that they are controlling. So for example, if this is my shoulder, this would be my shoulder underscore L in this case, underscore CT for control, right? And then we rinse and repeat. This would be our body underscore CT, our shoulder underscore L underscore CT. We have our clavicle underscore L underscore CT. And we have our hip CT. We have our master control, master underscore CT. And then our COG underscore CT. Right. Now we have to actually connect our controllers to the joints, and then we have to connect our controls to each other, right? We have to have a parent chain for these controls to work. Honestly, we could do it in either order. I'm just going to do the controls first, and then we're going to start parenting or constraining our controls. But before that, I actually have to mirror these. So these 4 controls, the best way to mirror them, you duplicate them with Control D, and then you press Control D to duplicate, and then Control G to group them. And I'm going to go ahead and slap a negative value to the scale X, and that'll flip it over to the other side. Super important. Make sure that you freeze transformations, and then you go on ahead and change these names to the right location. The quickest way to do it is by selecting everything, heading on over to modify, edit, search and replace names. No, it is modify. Modify, search and replace names, and we're going to be replacing the L with R for the right side. And then just replace, and that changes all of them. And then just delete the numbers at the end of the structure over here. CT. Oh, I have two shoulders here. What's that? Just delete one of them. Oh, oh, I see my mistake. I accidentally named shoulder twice. This is the elbow. All right, so this would be named it twice. Elbow. There we go. Elbow or arm, whichever works. Yeah, I'm not gonna police the names necessarily, but you do have to have names for this evaluation. Elbow. There we go. Got that set up. And once that's done, I can remove these objects from the group. The best way to do it is just by holding Shift and then P. Shift P unparents. You'll notice groups also kind of behave like parenting, where you can have a bunch of objects inside a group and then move the group. Everything follows along. Go ahead and delete that. And now we have our control set up. And once again, I can essentially parent my controls first and then constrain it to the joints. But I kind of want to showcase what happens when you don't. So I'm going to hide my skin for now. I'm going to hide our geometry. I have this little skeleton here. It's kind of looking a little goofy, especially with the eyes. And we're going to be doing some constraining. So constraints, they're kind of similar to parenting. Again, super simplifying this. The difference is that constraints can be turned on and off. You can have keyframes for them. Animate. So for example, if you have a character holding something, you can constrain that object to their hand and then move the hand and the object will follow. So things like swords, or if they're taking something or placing it on a table, you would do it based on constraints. In our case, and again, this is where riggers might want to look away, it's going to be the main way we're going to be setting our controls. Again, mainly because it's just quicker. It would take a lot less time to set up, and this video is already going to be pretty lengthy. So what I'm going to do is we go ahead, select our constraint or our constrainer or our driver, and then select our joint, our driven constraint. And then in our settings, I'm going to make sure that maintain offset is turned on. If it's off, it might break the position of the model. And then we apply. And now when I move this, the control now follows, or the joint now follows the control. And it's pretty much rinse and repeat from here, right? The order matters. You have to select first the driver, then the driven, driver, driven, apply, driver, driven, apply, driver, driven, apply. You have to do that for this as well. Driven, apply, apply, and this one goes here. Now that we have our controls, something that we've done is kind of broken our model a little bit in the sense that some pieces now won't follow the actual structure. So for example, if I rotate this joint, now this won't follow because it's giving priority to the constraint. So what I have to do to fix that, and you'll notice that if I try to just unhide that, if I try to move or pose, right, this arm no longer is following our shoulder. And that's because, again, this constraint is taking priority over this parent. So what I have to do is parent my controls to each other. So this goes parent child P, and then now we have what would be our expected deformation. Again, this is why, right, I may have to turn off comments here for this video because I might get hunted down by a couple riggers in the comments because this is not necessarily the way you would do it outright. The more proper or correct way is that you would have a what's known as a skin skeleton, which is what we've created, but then you would have a separate skeleton, and that one would drive your forward kinematic motion. So forward kinematics would be what we have created just now, where essentially you go from back to front, right? So shoulder controls arm control would control the hand would control the fingers, and then the fingers would work independently. And then you would have another skeleton, which is an inverse kinematic skeleton that essentially, well, it does the inverse. You control the arm from the wrist, right? And the wrist would control the elbow and the shoulder and vice versa. Um, right, but again, that would take a bit of time because then we would have to connect both skeletons and right, this is again just a really basic demonstration. And I'm saying the word basic lightly. And I just judged on the video length alone, right? We press P, and we press P, and then here we're going to parent these controls over to our body control. Essentially now if I move the body, the arms move, control the clavicle more or less, and control the arm, right? All I'm missing now is just the hips. We would have to parent these to the COG, and then the hip, or the main body, I should say, we also parent to the COG. Now, when we move the COG, everything moves around with it. Essentially, the body can now rotate. Now we can rotate the legs. And then lastly, we can parent everything to this master control. And that would be our sort of final step for this demo. Now we can go ahead and pose our character and actually work on some animation. And the way you could animate, honestly, from this point on, we could do some editing in the skinning, right? From this step, that's completely legitimate. Obviously, you would want to take care of the skinning earlier in this step, but we could definitely do some poses and then fix that. So I can showcase, for example, first, make sure I save. It's going to be our test. Just go ahead and name this final. So something that we could do is I could animate a pose. So select the shoulder, press S, and then move in my timeline, pose, press S, and then you'll notice that, right, you can see the animation, press play, you'll see the animation going on. And we can kind of work on fixing this from this position. So I can hold right click, paint skin, right click over my joint, select influence, and I might want less influence here, so I can swap this to replace, put that to 0, and then a lower opacity, so it's not as rough at the beginning, and I can remove the influence from the shoulder on the face, right? Because I don't want the face to be manipulated by the shoulder necessarily, because again, it just kind of gives us this sort of wrong looking deformation, and we can focus on one side and then mirror it over on the other. It's not perfect, but again, it'll save us some time. Go ahead and just remove that influence here. Right, so we can edit this, continue to work on this and fix it and iterate on it a little bit. Just go ahead and remove that entire influence. And now when we actually animate the arm, notice that we kind of have a slightly better result than before. Again, this is a bit of a time painstaking process. It takes a while to sort of get this right. Test that again. You can also make another keyframe and then pose it in the opposite direction. Kind of see how that looks. You can do stuff like, for example, selecting this edge loop here, maybe this region here as well, and then heading on over to skin and then smooth. That kind of gives us, right, somewhat a good result. But again, this process definitely takes a while to get right. You can go also ahead and right click delete these keyframes here once I'm done. Kind of just keep testing the rig bit by bit. But for all intents and purposes, the rig itself is done. What's missing or what needs to be fixed is the actual skinning. But you can totally animate with this. Some very simple poses, the exercise. And in fact, it's something I'm going to ask you guys to turn in for the class, do at least 1 or 2 poses, and then hand that in screenshots. But this is essentially it. Like, he's ready to ready to be animated, barring a few caveats here and there.